Hello, welcome to the first episode of Brain of a Penguin's YouTube channel. I am a penguin, and this is my home. But enough about me. We're gonna talk about you. You came here to learn about math, so let's get into that section. So, how do we multiply fractions? These large numbers may seem abstract and complicated, but don't worry, I've got you covered. First, let me explain my thinking and approach for new concepts in math. I think there are two types of concepts in math, explained and not explained. But what exactly do I mean by not explained? My example for explained and not explained is sort of like learning addition for the first time. You know how to do A plus B. You had to learn this concept from a teacher. Now you want to know how to add multiple terms, or C. You can apply what you already know, which is how to add two terms, A and B, and figure on your own how to add that third term. I know a teacher or the internet can teach you a concept quickly, but if it is possible to apply prior knowledge to intuitively learn something new, figuring out a problem by yourself is more efficient over time rather than a quick internet search. Okay, now let us get into how to multiply fractions. In math, there is always something called a given, a fact that you already know that you can base your reasoning off of. Here, we are using givens to observe a pattern and intuitively learn a pattern in how to multiply fractions. Let us start by looking at the first given on our page. Here, I am noticing that I can make the number 2 look awfully like a fraction by putting 1 on the bottom as a denominator, or the number in the lower part of a fraction. I know this is true because any number divided by 1 is itself basic division. Next, I am taking something else I already know, a basic multiplication equation, and converting it into a fraction equation. Here we know that 2 times 2 is equal to 4, and we can keep 2's equality by just dividing it by 1. It will look different, but it will be the same. Note that the fraction sign, or the line in the middle, is the same as a division sign. Because the purpose of going through all these givens is to find a pattern, let us try to find a pattern. Well, right away, I see that 2 plus 2 equals 4, and the denominator doesn't change. So, can a pattern be adding the numerators and keeping the same denominator? Let us test this theory with another example. Here, I took another multiplication equation. 1 times half is half, or half of 1 is a half. Here I divided 1 by 1 to make it appear as a fraction, as I have done before. Right away, I can see my previous theory is blown out the window, as 1 plus 1 certainly does not equal 1, and I do not know which of the denominators to choose. So, if addition is a bust, I have subtraction, multiplication, and division. I have an idea. If we are multiplying fractions, we might as well try and find a pattern regarding multiplying. Talking about multiplication, I can immediately see a pattern, multiplying the numerators and multiplying the denominators. Let us also test this theory with another example. Okay, so I have pulled up a true statement, and by observing, we can tell that our theory of multiplying the numerators and multiplying the denominators worked. So now I have the basic idea, and while I could have showed you this in the first minute of the video, learning concepts without it being fed to you is much more productive and strengthening in the long run. If you ever forget this equation, instead of having to search up how to multiply fractions, you can intuitively realize by using patterns how to do it. But what now? How can I strengthen my ability to multiply fractions? First, I see in this slide that I had to simplify fractions at the end. Is there a way to prevent this for me to be able to get the answer more efficiently? Yes, there is. One way we can work to reduce simplifying at the end is by checking if the numbers diagonal from each other are multiples of each other. Here, we can see that the top layer is something multiplied by 4, and the bottom layer is something multiplied by 2. Instead of unnecessarily multiplying, especially where we will simplify later, we can reduce the numbers before even multiplying. The reason behind this is 4 is 2 times something. This is the definition of a multiple. In this case, the multiple is of 2, meaning that 4 is also equivalent to 2 times 2. So if 4 is 2 times 2, and on the top, and something is on the bottom, multiplied by 2, this is the equivalent as multiplying just by 2 on the top. This form of reducing can also work on multiplying fractions with multiple terms. Remember though, you can reduce one at a time, and if the numbers are the same, they are still multiples of each other by 1. There is also one more way to simplify multiplying fractions before the actual multiplying process. If you take what you learned from the diagonal simplifying before, this obstacle should be easy. See if you can figure it out before I say it. Okay, the reason behind this simplification is that we are multiplying the top half of our fractions by 4 and our bottom half by 2. If we are multiplying the top layer by 4 and the bottom layer by 2, as I said before, it is the same as multiplying just the top layer by 2. Also, we can notice that we are simplifying this fraction. This will be the last type of multiplying fractions concept I will show you, which you might recognize as a whole fraction. There is also a section of multiplying negative fractions, but as long as you know how to multiply with negatives, the rule is the same. I can go over that in another video. To start on this example, here I have pulled up an example of multiplying with mixed numbers and its true answer. I will tell you right now that this is the correct answer. Sometimes we need the answer for more than a test. In this case, we are using the answer to find a pattern from before in the video. Well, I can start by noticing that this 5 upon 2 is an improper fraction, in this case a fraction greater than 1, and that I can easily multiply with it using our method from before. I know this mixed number is also greater than 1, so it would be safe to say that the goal would be to make our mixed fraction an improper fraction, because we know how to multiply with improper fractions using our developed method from before. If you know how to convert mixed fractions into an improper fraction, great, but this is the reasoning behind it for those with less experience. Here, we can see two true equations. I can use this idea to help convert the mixed fraction into an improper fraction by making the whole number part of the mixed number adapt with the denominator. Using the information from our previous slide, and using the knowledge that 2 and 4/7 is equal to 2 plus 4/7, we can convert the 2 into an improper fraction, moving back to our original equation of 2 and 4/7 multiplied by 5 upon 2, we can substitute our converted mixed number and multiply. We can also notice that 18 is a multiple of 2 and simplify. I trust that our multiplication is reliable, so I will not go into that. Here you can see the answer from before, and we can also notice that this answer is the same from our slide before, meaning that we have got the correct answer. I hope you can take the idea of a concept that needs to be explained and some that do not need to be explained, and take it into future consideration before doing a quick internet search. Do you have an idea for a future math video? If so, comment it below. Would you like more examples for practice? There are more in a Google document in the description. I call it the chicken NATO.